Okay, so then in this video we're going to be solving systems through matrices, and we've already solved systems through graphing and substitution and elimination, so this is just an extra method to kind of help you out. Alright, so let's first of all know how do I identify a certain matrix and its size. So a matrix is always it's going to look like a chart like this with brackets, and it's a list of numbers. And basically, to identify the size, we're going rows and columns. Alright, so let's see how many rows there are. We have one row here and one row here, so that's a total of 2 rows. Okay, and the number of columns, we have 1 column. Okay, we have 2 rows of numbers here and 2 columns of numbers. Then we have 3 rows, 2 and 3, and 1, 2, and 3 columns. So, normally how you would see this is you would take the rows and you would say by the columns, in which case this is a 2 by 1 matrix, 2 rows by 1 column. This is a 2 by 2 matrix. This is a 3 by 3 matrix. And so it would normally read like this. Okay? Alright, so right now I want to focus on this middle matrix. So I'm going to get rid of the other 2. And essentially I want to try and find the inverse. I want to try and find the inverse matrix. And the inverse is represented with, it's the matrix to the -1 power. And that's what the inverse is. So let's try and find it. And we're going to actually use the calculator to find the inverse here. So let's start off by, first of all, turning on the calculator. And I'll try to adjust my window just a little bit. Okay, I don't know if it helps, but okay, so how we're going to do this is we're going to go to second, and this x to the -1 power, right above it says matrix. So you're going to press that, and you should end up getting this screen. Notice at the top its names is highlighted. Okay, so we want to use our right arrow and go over to edit. So we're going to edit a matrix. Okay, number 1, A, matrix A is highlighted. Let's press enter, and this is a 2 by 2 matrix. So we're going to say 2, enter, 2, enter. And you can see it's a 2 by 2 now, and we have the first number highlighted. Okay, so then we're just going to take the numbers in the matrix, and we're going to say 2, enter, 3, enter, 4, enter, 5, enter. And you can see 2, 3, 4, 5, it lines up with our matrix here. Okay, let's see here. So, let's go ahead and quit this, second quit, go back to our matrix. So, names is highlighted, and let's go ahead and press enter because we have our matrix A is highlighted, it says number 1, and it's a 2 by 2. And so then if I press enter again, it pulls that same matrix up, 2, 3, 4, 5. Okay? If I want the inverse, then what I'm going to do is I'm going to select that matrix and take it to the power of -1, which is this button x to the -1. In which case, if you press enter, this is now the inverse matrix. And so we have -2.5, 1.5, 2, and -1. And that's the inverse. Okay, so that's kind of just notation. So let's find out how we can solve a system through matrices. Okay, so let's start out by solving, in my elimination video, we solved this matrix here. And we did it through, of course, elimination. Here, maybe I should pull this down so you can see. And let's see, and then it was 4x plus 8y is equal to negative 24. And we ended up getting the solution to be, after we found our zero pair and solved for y, plugged it back in, solved for x, we ended up getting 6, negative 6 as our solution. Okay, so let's see how we can do that with a matrix. So let's set up our matrix, and how we're going to set it up is we're just going to take the coefficients of x and y. So essentially this is my, the first column is going to be my x column, and the second column is going to be my y column. And so then, okay, well, if we're looking at x's, we have negative 4 and 4 and negative 2 and 8 for the y's. And so maybe I should move the y over. Right, there's my y column. And so that is this matrix. Okay? Basically what is going to end up happening is if we multiply it by the x and y, we should get this 2 by 1 matrix that is negative 12 and negative 24. So negative 12 and negative 24. And that's how you would set this up. It would look exactly like this. So then if I wanted to solve, basically I'm going to multiply both sides by the inverse matrix. Now let me show you what that looks like. Okay? If I end up multiplying both sides by the inverse matrix, I will have that negative 4, 4, negative 2, 8, inverse, times negative 4, negative 2, 4, and 8, times that matrix, is equal to, well, what you do to one side of the equation, you have to do to the other side. So we're going to take negative 4, negative 2, 4, and 8, and multiply that by the inverse. That's what we did over here. And then multiply that by, my screen's kind of going off. Let me adjust it slightly. Okay, so multiply that by then what's over here, negative 12, negative 24. So essentially this right here is going to be a unit. It's going to turn out to be the identity matrix. I'll just call it the unit matrix for now. But it's going to end up equaling 1, and you're just left with x and y. Okay? So let's solve for this. And I'm just going to do it through my graphing calculator. Okay? So you want to go, let's see, matrix, go over to edit, and it is a 2 by 2, so 2 enter, and we want to fill in these numbers. Negative 4, enter, and then negative 2, 4, and 8, and pressing enter after each one. And then we're going to go back to the matrix, edit, and we have, oh, excuse me, let me go quit, and matrix. Here we go. And we want to go down to matrix B. Notice that the B, number 2, is highlighted, because we're going to end up using this matrix for that one. Alright, so this is a 2 by 1, okay, 2 rows by 1 column. And the numbers are negative 12 and negative 24. Okay, so all we need to do to solve for my x and y are multiply the inverse of A, and I'm just going to quit, go back to my inverse, and now we're at names. So it's highlighted to 1, which is matrix A, so press enter, and we want the inverse of that, and then multiply it times matrix B. Go to matrix, scroll down to B, and once you press enter, it's 6, negative 6. When x is 6, y is negative 6. And you can see that this solution here is the same thing as this solution. Okay? When x is 6, y is negative 6. When x is 6, y is negative 6. And that's how you would end up solving a system through matrices. Now that's two-dimensional. Okay, let's solve one that's three-dimensional. So let's say I have a system that's here. Let me. Actually, no, I'm going to crop this out, and we'll do it on another video.